Hello everyone, I'm Zach Peterson and I'd like to welcome you back to another Flux tutorial. In this demo, what I'm going to do is talk about how to create parts in Flux, but also which of the methods you should use in different types of projects. Now, if you've seen any of the other tutorials on the channel, you know that there are multiple ways to create a part. I think one of the questions that comes up is, when should you use each of these different methods? We'll run over how to do this, when you should use these methods, and where you can access all the different features in Flux. Make sure to go online and follow along. There are three principal ways you can create parts in Flux. So the first way, and probably the easiest way, is to clone a part from an existing part that already exists in the public library or that already exists in your dashboard. So that's the simplest way. You can take an existing component that you've already created and start using it immediately. I'll run over how to do that in just a moment, but another very easy way is to actually do a plcaed library import. So there are a few different ways to do this. You can do this inside of one of your parts, or you can go up here to the menu on your dashboard, and then you see under here import, you can click plcaed parts. And now you have to have libs already on your computer somewhere, so those lib files have to exist already. And when you click on this button here, here you can see in my folder I have several libraries that I've already downloaded. But one thing you can do is if you actually go onto Google and then you go over here and search for plcaed library, you'll see that there are several different libraries that you can download. So there are some third-party libraries. Here are these organizations. They all supply parts for plcaed. You can also just export your plcaed libraries from your project and then import them into your Flux projects. Or you can get the symbols and footprints directly from the plcaed GitLab repository. So once you do that, you can import those libraries, select through those parts, and then bring them into your dashboard. You can also do this inside of a project. So let's just say, for example, just open up this project, and once it comes up, we can then go over to the menu, and from the menu, I can then select import plcaed parts, and then I can select one of these libraries. Now, once you select one of those libraries, a list will come up. You can select the list of parts out of that list, and you can then start placing them in your schematics. So there's another video by someone else at Flux who has actually gone through that process, shows how to do it. I'm going to link to that video in the description. So I think going this route with importing your old libraries into Flux is a great way to just totally migrate everything over to Flux. Or if you just have old projects in plcaed, you want to continue using those parts in your new Flux projects, this is a quick and easy way to do it. So another great way to reuse your existing data is to fork an existing part. Now you can do this from the dashboard, and if you're in your dashboard, you'll see here, for example, some of the parts that you might have already in your project list or in your parts list. You can then open those up and then fork them. Now, I was just in another project here earlier, and you'll see here that there's several different parts. So these resistors and capacitors, they were created from generics, but we do have an integrated circuit here. And one thing that you can do is you can right-click on this integrated circuit, you can open it, and then once it opens, you can actually fork it. Once it loads, you'll see an option to then fork the part into a new part, and then you can totally change all of the parameters. So you can change the manufacturer information, you could change the pin assignments, you can change the pin names, pretty much anything that you want. So once I'm in here, you can see I've got an option up here in the top part of the screen. It says fork your own copy of this LT1129 component. So once you do that, you'll see here it just immediately forks a project, and then it's going to make a copy, and you can then go in and modify the part, give it a unique name, do whatever you want to do with it. One reason that you would want to then fork one of these parts is to reuse, obviously, some element of that part. So, great example, the footprint. Let's just say here inside the PCB editor, if we look at the footprint, you'll see that we have this package here. This is an 8 SOIC package. Now, if I wanted to reuse this same footprint for a whole other component, totally different component, totally different function and everything. This is a really great way to do that because it completely cuts out half of the work that you would have to do in creating a part. All I would have to do is go in here and then select each of the pins, give them new pin names and pin numbers. And then once I do that, I've essentially totally recreated the part. You can also do or recreate the pin arrangement to match the data sheet if you like. So you see we've got pin 8 here, we've got pin 5 here, so they're a little scattered around. But here in the PCB, you don't actually need to change everything in the PCB. You can just do it in the schematics, and those will match up on the PCB. So here, we can also change all of the manufacturer information. So you can see here, this is set to analog devices for the manufacturer, but if we're reusing this SOIC footprint for a new part, we would then change all of this manufacturer information so that it matches the new component that we want to use in a new project. Now you'll notice that I opened up this particular part from inside of this sub layout. But I could have also started from the library and maybe found a component that I already wanted. So let's just say we want to find like a QFN component. We want to make sure we select items with footprints. So if I then select one of these, I can drag it into this project, and then I can do the same thing. Just right click on it, open it, and then fork it. And then I have my own copy of that part and I can start modifying it. So we started off by looking at the symbol when reusing a part, but sometimes you may want to copy a part or fork a part and then put in a new footprint. So you can do that from the PCB editor. Inside this PCB editor, we could totally change all of these pads, and we could change any of the other layer information we need to change. Sometimes if you're going to do a new footprint, it just makes sense to do a totally new part. And there are parts that come out on the market and they may have a totally unique package. So there is no other part that you can just copy and then use that to create a new part while keeping the footprint. So in that case, you're going to want to start with a brand new part. So here what I'm going to do is show you just how to get started creating a brand new part. And specifically, I just want to focus on making sure the pin assignments are set up correctly. So before you start making a new part, there's something that you should do, which is you should go over here to the PCB editor, right click under root, and then add, and then footprint. Once you do that, any pads that you start adding in, or any terminals I should say, that you start adding in the schematic will then appear in the footprint. First thing that we need to do with creating this part is give it a designator prefix, and then we're going to need to add another design rule, which is part type. So these are the two basic rules that you'll need for any part. The next thing that you'll need after that to take this, kind of phony part and turn it into a real part is to give it a manufacturer part number and then a manufacturer name. So we'll add those two now. Now we don't have to fill them in immediately, but we do want to make sure that we include those in our part. So now that I've added those in, I can start adding in terminals. Now as I add in this terminal, it's going to be automatically assigned a designator. The designator appears right here in the schematic. So if I change this to, let's say, VCC, you see that this also changes to VCC. There are some other properties that are automatically assigned to this terminal. And I can give it a pin number if I like. I can give it a pin prefix. I can change the pin type if I like, whatever I want to do. Just by default, I'll start numbering it as pin 1. Now once I go over here to the PCB, you'll see that a new pad appeared in our PCB layout. And this pad by default is circular, but this pad is our VCC pad, so you can see the designator right here. And it looks odd because here you see the top solder paste layer is enabled. So if I turn that off, now you can see the top solder mask opening is visible. And then if I turn that off, you can see now the top copper is visible. And as soon as I turn that off, you see that you don't see the pad anymore. So by default, it's a circular pad sitting on the top copper layer. To make sure that you can clearly see the copper, it's best to just turn off the solder paste and solder mask layers here so that you can see the copper clearly. So once this pad is here inside of the PCB layout, what I can do is go down to the object specific rules, and this is where I could set the pad shape. So by default it's the position that's visible here, and it's by default it's just set to 0, 0. It's a good idea to move this either manually to put it where you want, or just to set it exactly where you want it. One of the conventions with parts is to set the origin right at the dead center of the part, and then to arrange the pads around it. So the information in a data sheet can help with this. One thing you'll want to do here is then go to Edit under Object Specific Rules, click Add, and then Size. So this size rule is what is going to allow you to then modify this pad so that it matches the values in the land pattern in your component data sheet. So just for example, we'll make this let's say 1 millimeter by 0.5 millimeter pad size. When I do that, you can see here it automatically adjusts the pad size to match the value that I selected. So you can modify the layout rules that you assign just as you would with any other object inside of the PCB editor, and it will automatically update. So as you add in these new terminals, they will appear in the PCB footprint, and then you'll be able to arrange them to make the component. So the last piece that you'll need is to create a symbol here that accurately represents what you would like to show inside of a schematic sheet. So to do that, I'll invite you to follow along with the video that we have linked in the description. It actually goes a little more in depth on how to do this with a custom schematic symbol, and make sure you go watch that video and follow along with those steps. So the last thing that I'd like to point out here is how to add in a custom symbol that will appear up here under the new part area, so you can change this logo here. Also how to add in other assets like a 3D model. So down here under the Assets tab, you can see there's an Add button. If I click Add and then Add Item, you will see that there is a dialog that opens up with a set of files that can be selected here. So this is where you would go to then select those other files to add in and start using in your new component. So I'll run over how to do that in an upcoming video, but for now I hope you enjoyed this video. Make sure to follow along with all of our tutorials, and you can get alerts on new tutorials when they come out by hitting the subscribe button. So make sure to do that. And of course, if you want to start using Flux, make sure to go to plcaed and you can start using